This video is a follow-on from the Pavement Attributes and previous videos on subdivisions and overlay and widening. This video pertains mainly to the construction field and also possibly design ran at a later stage during your MTF. Construction design strings are usually given as one model. As you can see here, there's several roads, side roads and possible drains running back and forwards here that make up the entire job. In order to utilize the attributes for the pavement and the snippets that were shown in the previous video, we need to be able to make access to the apply many options and be able to recreate the design from the construction strings. The design looks like this, so when you do an actual design, you need to then manipulate the data and put certain things on other models. So what we're after is this data here. We're looking at just this main thoroughfare road, and we're going to end up with that. So again, all the side roads, the drains that come back on themselves, turnouts and all those sorts of things are put on a different model. And this is the road that we will look at. We'll look at that one in a moment, but we'll go through to a previous job that has all those things cleaned up. So this is just a simple road straight through, curb and channel, some right turn lanes and so forth. So the design strings have names, normally some sort of naming convention, and we need to recreate a design apply many from that. Having a design apply many is quite useful for lots of different fields, not only for the pavement but also for creating polygons and subsequent information on design. So under design, apply, we grab apply MTF recreate. So we're going to recreate and apply MTF that the designer would have used to form part of this job. So that's for model of strings, and this is just the design RSO1. Ask you for reference alignment string. We're going to pick our alignment string. You can use a hinge string, and we'll explain what that is later on. But for this stage here, where everything's about the reference alignment, so we need to pick some changes. So pick our reference alignment and snap onto here. So there's still a fair bit of onus on the construction people to fix this data up and join strings that need to be joined to give a continuous travel lane and things like that. So there's still a little bit of work in regards to that. So at the moment we're just getting the start and end changes. So it'll just take the name of the reference alignment, but if you do want to put in your own function name, you can do that here. There's a create edit file for a layer file. In that case, then it will take some strings that you don't want to be as part of your actual design profile. Normally you may have already done that and moved those strings to other models. View for display, and we go process. So we now have our design MTFs. This is my original data. So under the models here, we now have an RSO1, and we have 4 models. One's the construction data. So the construction data is just a copy of your original data, and the string names are adjusted to suit for use in a design MTF file. So you don't ever touch that data. Any updates that you want to do for your job, you do on the original design original data here. There also are sections created. So if we get rid of the original design data and add in the RSO1 construction strings, It's just a reproduction of the actual design, but inside a Design MTF. You can edit the function by just picking that and picking a cross section, and it brings up the apply menu function that had been created. And if you wish, you can actually run the cross sections or the design cross sections closer together. And if we apply that, we now get our cross sections closer together, depending on what you want to do there. There are filter cross sections created as well that you can then profile and step through rather than stepping through all the design ones. So again, if I go on profile, my design section, that's what I have. If I add in the RSO1 construction strings, there's our reproduction of our design. So remember, any changes that you would do, you do to the original data, and which is the design RSO1. Then you can come up under design, apply, recreate. There's an option to update. So when you go and pick the RSO1, it gives you information about the data that was used, the alignment string. When you go update recalc, it then redoes your design. It doesn't delete any of any subsequent design you've done in your MTF file, but it just updates a snippet that reflects the design surface. Speaking of the MTF file, if I then select a Design MTF, this is the one that gets created. So on the left hand side of the road, there's a alias set up for the start and end, and this is the actual design surface created from the external strings. It's inside a snippet, and when you run the update that I showed before, this is the file that gets updated. So obviously the MTF uses this file, so any subsequent things you put in here will not be deleted. So if I look at the MTF file, and I now wish to look at doing some boxing or subgrade. So again, on the previous video, under the Snippet Pavement Attributes, you would have been able to see how to create and read and write these particular pavement attributes. So this job here, we've got several reference styles. So this one here is for the design part urban that we're doing now. The other one's for a highway design, left hand side and right hand side. So in the styles, if we drop down to reference style, this is the model and naming convention. Just a quick recap on this. So again, the layer name inside the MTF file is called pavement. The models that it created would be called a combination of mesh pavement and mesh strings pavement, along with some other suffixes that you are able to add at certain times in relation to the normally the reference alignment string. So again, inside the zones here, I have one for curbs. So in that case here, I do have a curb profile, and I'll set up a curb layer. This is one that is a curbing channel. This one here is just a bus drain. So again, under here for a curb one, you've got the curb profile, different layers that support that particular design profile. So again, this is in previous videos. You can have a look at how to add and create different styles and layers and zones. It's enough to say that we have a pavement curb, pavement only. So we're also looking at layers like that. Pavement only down here, for instance, is just for island pavers. So we've just got the pavers plus a bit of sand base layer. So again, we have all the different styles. You have up to 10 of those, 10 zones and 10 layers. So hopefully that'll be enough to define your design profiles. So again, these are run inside a MTF file. It doesn't take too long to get used to how to use the MTF file and the snippets that are provided. So here you just go double click and pick snippet. So I've copied the snippets that we're going to require into my working folder. It's quite a good idea to do. So all the ones that refer to the pavement attributes that I have over here all have the words from attributes after them. So we're looking at a curb from attributes, so we select that snippet. So again, a snippet asks you a few questions. Most of the information in relation to pavement types and depths and so forth are all stored in the attributes. So here we're looking at relative to alias start, and this is one defined automatically for you for the full extent of the job, and relative to alias end. So looking at reference style 1, zone 1, so if you still don't know what they are, you can drop over to here. Reference style 1 is a curb, type 1, curb and channel. So we default the extra suffix that's going to be added to all your model names. We're going to use all characters from this, which means it'll use the RSO1 name of the alignment string. We have different start modes. This is the start area, that's the end area. So in this case here, our start mode is just reference string, but you can obviously pick other types of reference string. In this case here, it'll pick that point. A 3D cut link would possibly be a lane line out here instead. We'll look at the first link of our job, and again these are similar to curves, but it is just any curve profile. In this case it is a curve and channel, but it could also be a curve only, or even just a concrete edge or a drain. So the first two are mandatory, and the other two are optional. In this case we want to use all of them. So we're going to pick all those strings. This is where you would have done a bit of work in the prep work to make sure that the strings that you are selecting for your pavement and your curves have good naming, a good naming convention, and are continuous along the job for as much as what is possible. So in this case here, it all comes along. So if we go back to our section view, right, we're looking at our pavement under the curb. We're just going to use the road surface, and there's an option here for an alias, and basically it's the actual extra name or an extra suffix that can be added to the strings and the subsequent tri-mesh. This job is running the full length of the road, so I can not have to put the suffix in, but it is also sometimes a good reason to do so. So if I apply that, it'll go through and recalc my job. If I go next onto my cross section, and now the model that I have again is under the pavements, so it's going to be mesh pavement, and then the roads RSO1. So add in the mesh pavement RSO1. So we go F2 and just change the option to 12D Inquire. So when I do pick on these tri-meshes, it'll give you information under tri-mesh about the layer description, where it came from, the layer name, especially the reference style, what type it was, pavement curb in this case, and a bit of information about the depth of that particular layer and the reference alignment string that it belongs to. So again, you've got different layers here. You've got the curb profile, and you've got the AC services and related information. So if I go back and look into here, and we'll add in our design, our mesh pavement, RSO1, and have a look. So this is the pavement profile and the curves. So you'll notice here that in this part of the road, we have a possible driveway. So there's no actual curve profile there at this stage. And so in that case, the string head was one of the backer curb strings didn't exist. So if any of these strings, these three here, don't exist, then no curb shape will get created. But if the curb lip string does run through, it will at least fill in that part of the pavement. So that's just done automatically for you. So I was doing the curve profiles. So if I go into this part here, again, if I go back to my reference style, if it was one of the lane lines instead, so I could drop out here and pick 3D cut link. I go center mouse button and pick one of those, and again go apply. So this case is actually forming the part of the row profile, but only out to the lane line rather than the reference string, depending on what you're after. Another process besides doing a curb is for doing things like pavement only. Pavement only can be applied to roads as well, and drains, and also just footpaths. So there's no curb involved, just the selection of some strings. So again, we're going to run snippet. The snippet I want is a try pavement only from attributes. Right, so the pavement only I'm after in this particular job is to do with the footpath. So I drop down to here, and I'm looking at pavement only. Scroll down. I'm zone number 3. It's the island pavers. In that case, it's got pavers and a bit of base layer. So again, that's just the style related to our design and urban. So we're looking at pavement only, and we're looking at zone number 3. So we've got pavement only and zone number 3. The snippet type selected defines where it looks for the style. So in that style, it automatically knows to look in the pavement only area rather than anywhere else. We don't want reference string, we want 3D cut link. And the 3D cut link is the footpath string. The end link is also the other side of the footpath. In this case here, you can actually have a depth type. So in this case here, either vertical or normal to the surface. But we just want vertical. We'll do in this flattish footpath. So here's our footpath profile with a curve only. So we're looking at our footpath profile and our road surface. So again, checks are done in relation to the existence of strings. You can actually just go from start to end, and it will only produce the pavement or the profile for the footpath where these either of these two strings exist. So a lot of the errors are taken care of for you. So that's the general profile of a road surface, and again you can introduce different lanes, and you also have one for a batter slope for a rule type intersection, and we'll have a look at that in another road. So that's just the running of the Design MTF or the actual recreation of the Design MTF from your supply construction strings. And again, it's imperative that you understand that there is a lot of, or a reasonable amount of work done on checking the names of the strings, joining continuous strings, getting rid of data that doesn't belong to this main thoroughfare road. As I said, you've got to remember in the Design MTF field, generally strings just run parallel to the road. You don't get any strings tuning out and going back on themselves. So in this particular row, we've looked at the snippets run inside a Design MTF. So there's not too many commands to look at in the Design MTF, but there are other ways of being able to produce your pavement. So if we add in our second road, right, some of this has been pre-done before. So again, the same story. This job has been set up. Here we have a large intersection that's been taken out and put onto another model. Some of these strings have been trimmed off or adjusted to suit different curve profiles. So we're looking at here, we've got a curb and channel running all the way through to here, but then from there on it's only curb only. So these strings have different curve profiles. This one's a drain for a bus bay. So we have done a little bit of work on running those strings. So again, if I look at the Design Recreate for RSO2, so we're looking at the section strings. So the same process under the Design, Apply, Recreate. Pick the model, and it's recreated the sections for me. So if I now look at the MTF file that was used to create that, Exactly the same as before, it has a start change and an end change, but sometimes you'll find that there's certain strings that have bends in them and so forth, that critical information or a critical cross section hasn't been picked up. So that's achievable in your MTF file under More, under Specials, Values. So you just basically can pick a change point or a vertice on your string, and it will produce an extra cross section for you. So if I went into here, went right mouse button, and I went typed, and I picked this change box, it'll then run perpendicular to my reference alignment, waiting for me to snap onto a point to produce a change to get an extra cross section other than your normal design interval. So that's how these particular ones were created. So if you do have a critical point and you want some extra sections, that's under the More Specials. So Design MTF file, there's as we've seen in the other road, we can run the snippet and pick strings and produce the pavement profile. So there is another way of it. If you look at the other road, if I just save and finish that, if I do look at the other road, this particular snippet worked well on my road, picking one string here and one string there, because there was a constant crossfall. There was no changes in crossfall here. So inside the MTF file at this stage, you can't pick a multiple surface here, and it will follow the profile. To get that to work, we'll look at another process. So again, if I go to my section view, and if I profile one of the sections. So again, it does have some general crossfalls, but it's just another way of approaching it. So you can specify the pavement profile via a colored polygon on your tin surface. So again, this design has been design sections and strings have been triangulated to form a design surface. So to create polygons or colored polygons that reflect areas on the road that you are going to have a particular type of pavement, you can go under Design, Cross Sections, and select Cross Sections Multi. This is a function, so it obviously can be recalculated at any time. So we already have one prepared here before, so I'll grab RSO 10. Right, so it picks up the cross sections that you created from the Design, Apply, Recreate. It asks you for a model, and also the tin, so it automatically colour the tin as you select the strings to create the polygons. So the strings are just a combination of two. So in that case here, there's a centerline string left and right automatically created for you. That's the CLL or CLR string, and you can pick the other string. So here we're going to create a polygon from the centerline right out to the lip of curb, and from the centerline out to this string here, which is the right turn lane. We're also looking at the bus bay area. So in the bus bay area, we're looking at the inner edge of this curve and that curve there to create the shape in here. You can define the polygons by changes. So in that case here, you might want to stop a particular polygon. So we add the polygon model on so you can see the tinned polygon model. So we'll add on RO2. So here's the polygons that get created for you. So you've got and they all will reflect a pavement profile or a pavement type, which obviously could change as it runs down the road. So we've got a yellow color here we've adopted for a type 1 pavement. We've got a type 2 pavement for the bus bay area, and we've changed over part way through here to an orange, which is the type 6 pavement. Alright, so it will create these polygons for you, and then those polygons are automatically used to color your design tin. These are generated from the Apply menu. You can actually draw your own polygon if you wish, and color your tin normally under the tin's color by polygon option, and you can create some quite irregular shaped polygons that reflect a pavement profile. So once we've used our cross-section coloring to get the colored tin, if I take off that and add in our tin, you'll see this all now coloured. So the strings that are produced that way. So if we go up under tins, retriangulate, okay, we've got our triangulation there without the colouring. So again, if I edit the function, which is the RSO2 tin polygons, and again process. So during our process, it creates the polygons again, and then recolors colors your tin surface for you. So if I then look at the how do I then apply my pavement profile or my pavement type to the coloured area. So in this case here, we've only coloured the yellow. The original cyan colour is the original colour of the tin. So we're only interested in the colours that we've done. So under user beta pavement, this is where these options will be for a while, and until they make their way into the menu system. So pick one here, pavement create from tins. So it asks you for a function name. So in that case, we've already had one before, so we'll grab our RSO2 pavement from tin. Right, so if I look at my pavement profile, we're going to look at our design surface mainly for the tin surface. You simply ask for a colour, and then what style of pavement that you wish to apply to that surface. So in that case here, if we're looking at our road profile, the design surface, we have a choice here, either curb, pavement only, or batter, depending on what sort of pavement that you're looking at. Because these are created by the tin surface and not part of the MTF file, we need to add a suffix similar to what we did in the snippet. So we're just adding RSO2, which is the name of the road. So in this particular profile, it's going to assign this pavement to all these different colours. So if we have a look at just the one surface at a time, and we'll process. So we add in our mesh pavement, RSO2. So here's the mesh pavement again, and if I do an F2 inquire, you'll see that the pavement stops at the lip of curb string. So this is the pavement that was created from the coloured tin. So how was this area created? Because the tin surface stopped here. It didn't go into the tin. It's quite a complicated process to create the surface and the curb or the pavement underneath the curb. That was done all as one process with the MTF file in the previous road, but when you're doing a coloured tin and applying a pavement, you can't do things like this. That's why we've added the thing called edge treatment. So we're going to look at the edge treatment. It then allows you to select strings. So these strings are similar to what I picked inside the other road in the MTF file, where I selected the curb strings. So these edge treatments are also available outside of your MTF file. So these strings have been copied. Those 4 strings there have been copied onto a separate layer, separate model called edge treatment strings. So in this case again, we're picking the 4 strings, and they also can be, these 2 are mandatory and the second 2 strings are optional. There's a search width. So search width is just the distance from the first string outwards. So in this case, a meter should be enough to take into account the curve profile. So that's how the edge treatment for a curb is done. So I go to the edge treatments here. This is the RSO2. So if I take out the strings to do with the bus bay, you'll see the only strings left in this model called edge strings are the lip of curb and the invert top and back. So again, as we discussed before, where there are no back curb or invert strings through here, there will be no pavement produced. So as I decide to do the other areas, I wish to do the pavement. So if I go back to my job here, and I start to add in the pavement. So again, if we add in this pavement RSO2, and again we've got our curve profile, we'll add in our sections and strings. Right, so we're now looking at the area where the bus bay is. Okay, so the main process or the main curve profile has been completed using the coloured tin and the edge treatments for those strings. So all the curve profiles done. Now we wish to do the bus bay area, and it's a separate type of pavement. And as we showed you before, we had coloured that area magenta, which is the area that we wish to place a different pavement for the bus bay. So if we then again turn on our design tin, we're going to colour magenta. It needs to be a pavement only this time. Okay, and it also then has a suffix in there. It's also got an edge treatment. So so the edge treatment of this one is not being used at this stage. So all it's going to do is colour that surface. So we process. Again, it's now produced the pavement for the bus bay. So again, it's only the coloured area. Anywhere else in the tin surface does not have any pavement applied to it. Right, so we now we've got our pavement done for the major part of the road and the bus bay. We now wish to do the curb profiles here. So we do want a bit of pavement underneath it to reflect what's going on. But there's no actual colour associated with this area here. So where my curbs are sitting in this drain here and this curb only, there's no actual tin colour there that's going to that is needed. So if you only just got the strings and you just want to create the curb shape with the pavement under it, you can change the colour option to no colour. So in that case here we select no colour down the bottom. So that's just enough to know that it will only ever create the curb string profile for you, and that's all. So if I make that active and I drop over to the edge treatment, it's going to pick up the shape of the bus bay strings. And again, it depends on what you want to do. Sometimes the strings themselves, using the string as the lip of curve is enough, but sometimes if the strings do a bit of a curve and a profile, you may be better off referencing to a alignment string. So in that case here, I'll just reference this one to an alignment string back here. So when you look for a search width, make sure you pick a distance from the reference line that takes into account these strings here. So if I run my process now, it's now going to run through again, do the colouring. It's going to do the curve profile, and this time it's going to pick up the profile for the strings. So if I go into the profile here, it's now picked up our curve profile and put some pavement underneath it. The pavement under there matches the pavement next to it. So if I go 2, you see it's a different profile now. So if I'm looking at the profile now for the curb only, so again it's just a matter of strings. There's not any coloured pavement. We've already done the pavement at the bus bay. So again we tick this on and we're looking at only the strings. So we're picking up the no colour option. So this is the curbs only curb. We're also going to do another process for the footpath out here, so we might as well turn them all on. So under here it's picking up the footpath edge treatments, and then also picking up the back of curb strings for the, see in the back curb, there's only the invert top and there's no back string. So it's relying on the coloured pavement to relate the pavement profile to it, and also any edge strings. So it's always handy to colour the edge strings or place the edge strings onto a different model, so that when it comes to picking those edge strings, you're not picking all the strings that come from the original design. It has to step through all those strings in order to find the ones that you're after, so it's a lot faster if you just copy the few strings that you will need onto another model, and just give them nice unique names. So in that case there, it's produced the footpath profile and everything from the coloured polygons and edge strings. So it's two ways of approaching it, via the MTF file and using the snippets, or in this case a coloured tin surface. So as we can see, the coloured tin surface is fast and does allow you to create your own shaped polygons that could be quite irregular, that would be unattainable in the normal design process. We'll now look at the highway type job. So in that case here, we've got something that's similar, strings that create the actual design. Work's been done to take away any off ramps or side roads, and strings have been looked at to have a good naming convention, nice continuous strings that help in the creation of the pavement polygons, and also the continuation of the edge strings. So again, in this particular job here, it created a Design MTF file. So if we look at our cross-section profile, and again underneath our design cross-sections multi, we have a highway profile polygons. So again, it's also picked up the different strings. Red defines the main road, type 1, type 7 we've got on the other side of the road. We've even got some grass areas and polygons created. So if we have a look at our job here, or back in our perspective view possibly, and we look at our highway pavement polygons. So there the polygons created. Said that having nice continuous strings gives us some good polygons. So we can look at the pavement applied to a coloured tin and have different pavements depending on what profile. In this case here, we're just doing a grass profile in that particular road. So again, under our reference style, we're looking at our reference style there. So again, we've got zone 1, just a drain curve. Down here we've got a drain base. And if we go back down to the reference style 3, which is the right hand side of the road, and these are all the layers again. Layer 2 is the grass batter. So we've set up styles and zones that pertain to each road that we can either use in the MTF file or apply to a coloured tin surface or road edge strings. So we're going to utilise the colour polygons to start creating some of the pavement. So again, if I have a look at my pavement from tins, and I've got a function, this is the highway pavement from tin. So again, we've got some already pre-done for you just to speed things up. So we're looking at the red coloured surface. So again, it could be a change in crossfall, even an extension past the centre line. So an area that a coloured tin will reflect a lot easier than inside the MTF file. So again, it's going to be all on RS20, and in this case, so we process that, and we'll add in mesh pavement RS20. So again, this is the part that's being created. So I go back into here, you can do mesh here and do a quick search, mesh pavement RS20. So that's the pavement that's being created. So that's the pavement under the tin coloured red, and it's got a particular style and so forth attached to it. So again, under the other side of the road was the mesh for the magenta side of the road. Has a different pavement profile, maybe a different style, everything you can think of, and we process. Again, it's also going to be on a model, and that model is the other side of the road. So that's mesh pavement RS10, which is a profile there. So far in our section view, we've got the two profiles created from the road tin. So obviously for pavements like this would be a edge treatment, and the same for these two sides here. So we can't get the tin surface to go out there and produce anything other than through the edge treatments. So if I look at the edge treatment for the red road, or the red area on road number 2, and I pick the active button. So again, it's going to look at the edge treatment and so forth for this side of the road. But before we go through to the quick edge treatments, we'll just go through the manual way in the MTF file, just to give you an idea of what it actually is doing for you. So on the left-hand side of the road, again, these snippets have already been pre-done just to speed things up. So for slopes and things like that, a lot of the snippets require a surface. So in this case here, we call them name grades. So we can, under the fixed name grade, we can specify a grade name. In this case, it's just a -50%. So the snippet I want is a batter one. So again, it's picking up the reference style and the zone number that I'm after, similar to that first row we did. We've got our characters, all characters, so allowed on the RS10 reference alignment name. It's picking up 3D cut link, not reference. So it's picking up this edge string here. So you'll see this is actually a 5% crossfall compared to 4% on the road. So we actually defined where our coloured tin surface is used and where our edge treatment is used. So we're picking up our edge link, and we're specifying the batter via a name grade. You can also specify a batter via links and pick an actual link string over here. So in that case here, we're looking at the bottom surface of the pavement. We're going to leave as the start and end points. In other words, there's 5% grade here. So recalc our road. Right, we've now specified the pavement for that side. So again, if we look at it, it's a separate pavement, still on the same model, and it still has the same naming conventions, LUZ, and these ones are LUZ as well. So again, it's easy to quantify which ones are which. So that creates the pavement on the right-hand side for the edge treatment that we'll show you in a moment. So this side of the road is also on the right-hand side. If we look at the pavement here, the coloured tin allowed me to go right out to past the centre line, out to this area here. But to do the tin surface, or the coloured tin, cannot do this sort of pavement. So we have a look at what that pavement is. It's called a pavement only. And again, it also asks, when you run the snippet, for a name grade for the batter and so forth. So we've created those name grades prior to running the snippet. That's under fixed name grade. So the pavement only allows you this sort of information. So not only does it allow the pavement, but it also allows stepping in certain layers. So this is reference style 2, zone number 2. So we drop down to reference style 2, pavement only. We drop down to zone number 2, and we have a look at our layer here. You see there's an offset. So this is the outer offset, this is the inner in here. So it's actually gone out 0.3 of a metre, and then the other layer here has gone out 0.2 of a metre. So they're the offsets that you can create by the pavement. So in that case here, the tin surface would not be able to generate that. So as well as being able to select the strings and simply the type of pavement that you want, there also is another snippet called a verge snippet, and it will project this crossfall across to the slope and do the verge infill on top of this pavement here. So again, it's called a verge only from attributes. If we turn that on, it's very similar to the pavement only here. So it asks you for a string and a edge string. So in that case here, we're on this point here, so we can pick the same point. But you could have also, in this case, sometimes gone from 2 strings like that. It asks you for the batter slope to intersect, and I've started to use the alias name here to define. This could be like an A1 and A2, which combine to form the edge profile for the shoulder. So if I run that, then again we'll have a look at our profile. It's now produced this for me. So as you can see, this is something that the tin colour and application would not be able to do. So the profile automatically extends out to this area here. There has also been added to this snippet a cutoff link. So if you want the pavement to do a vertical cutoff here, you have to introduce a string into your well, the best way to do it is introduce into your design surface. So in that case here, I've got a string that's going to limit, called cut1. It'll limit where this is, and it will chop this off rather than extending or daylighting it out to there. So if we run that, and again next, so it gives you an idea of what these edge treatment ones are going to use when we go to run them. So behind the scenes, they're running the same thing. They're running a snippet and passing information down to the snippet as what we've done manually here. So you have the choice to either do it in the MTF file and have control, or a bit more control of what you're doing there and what you're choosing, or you can let the edge treatments work it out for you. The edge treatments do rely on you creating and naming strings correctly, and also a decent tin surface, or a very good tin surface, because it does actually drop onto the tin surface to get name grades and so forth. So there's a bit of importance on having all that correctly done. You can also do simple pavements just on strings isolated from your reference alignment string. So in that case here, we've got a curb barrier, and it's just a simple curb only that we the curb one, but this one's a curb only, so all you want to do is just produce the curb profile and so forth. So again, it just asks you for the strings, a reference style, and so forth. So if we then run and apply that, it will then create that curb profile for me. So the curb profile is that profile there. Again, you could also can add a profile into here. Now this curb one, I said it's reference style to zone 1. If I drop down to reference style to zone 1, you can see there's only just a curb profile. There's no pavement underneath that, because the normal curb profile has an offset and can only offset on one side of the curve. I want to be able to produce a bit of pavement under here that's offset on both sides. So I just use a pavement only option. So the pavement only option, as you notice, it can actually attach to strings that are created when you first run this one. So we add in a model called Design Pavement Strings. Right, besides the tri-mesh being created, there are also strings created for all the tri-mesh. So there are strings created at the bottom of this curve on a layer inside the Design MTF called Pavement. and you can then attach onto them to apply another bit of pavement underneath other than your design surface. So here I picked up that string. This is the A, that's the Z string, and they're on a layer called pavement rather than design. So again, same process, apply that. So you can actually then attach pavement only mainly to the bottom parts of strings that you've already created from the actual design surface. So we're starting to build up our profile here. So again, if we that's how the edge treatments are done inside the MTF file, picking things and setting up the strings. But we'll look at this side of the road here for the edge string options. So again, the edge strings are then copied onto another model. So prior to that, we go to our edge strings for the highway. Alright, so all the edge strings to do with the shoulder over here and here, they're all copied onto a model, given nice individual names and nice continuous strings. So rather than using the MTF file, we're going to use the edge treatments to produce the infills or for this side of the road. So again, if I bring up my highway pavement, before we get too started on this one, the one we had before, besides the colouring that, we also had a green one that did the pavement here for the road surface. Again, I just turn that on and go process. It'll run through, create those, then create the two surfaces for me, which is the road or the grassed area. So again, the edge treatments that you're going to pick here will reflect exactly what's happened over here. You'll pick these two, define these two strings, and you'll also define the pavement type. What you don't need to define is the name grade for these batters, because the edge treatments in here will work out the name grade dropped onto a tin surface in order to create or daylight or stop the pavement. So again, under here we've got a edge treatment. So we're doing this side. So we picked up that string and that string as our first and shoulder string. We've also introduced a cutoff string. So that's that string there, which will do the cutoff similar to this, or exactly like that. So the same idea. These things here are all what you picked here manually. These are all passed through to the snippet in running this tin pavement option. So it's got a search width, which is generally just enough distance here to pick up these two strings here. Process. Again, it's now ran through and produced the pavement for me. So if remember, that's the one created by the tin, and this is the pavement created by the edge treatments, or exactly the same as what was created over here. So on the batter treatment over here, we wanted possibly a different pavement, whatever you may have wanted. So we're going to define the type of pavement to be a batter. So when you define batter, it allows you to pick two strings here, and it will then produce the batter surface rather than the pavement only with steps in it. So again, if I turn that on and bring up the option here, it's picking up these two strings and just gives me a search distance from one string to the other. In this case, 5 meters would be enough. So I'll run through, apply all that, and then go and look at applying all the edge treatments and so forth as well. So again, it's running through, doing quite a bit of processing. We're always endeavouring to speed things up, but on some of the large major highways, things like that you may be doing, it might be a good idea to break the job up into reasonable areas. So again, the matter of colouring the polygons and then specifying edge strings on separate models that are nice and unique in names and define what you're doing here. So obviously, if some string doesn't exist, then the edge treatment won't get created. So That's the process on creating, again, for colouring a tin to produce pavement, blocks of pavement underneath the tin surface. So no matter what this road surface does up the top in relation to crossfall, the pavement will follow that profile. And then the edge treatments that you may be after. So you've got the choice to either do the edge treatments as part of this or do the edge treatments in the MTF file. Both will give you the same result. There was an option here to tick on a create subgrade tin and then a suffix name. So the tin was called Design Highway, and I've turned it on for these two areas here. So if we add in those two, it takes the name of the tin surface and adds in the suffix subgrade to it. So if I minus off the pavements, you'll see this is the tin surface that gets created. So we're looking at a tin surface under it's just the last layer of the profile that is created as the subgrade layer. If we do look at the profiles that are created on the outside underneath these pavements, so again under the reference style here, that's the urban one for the left hand side. So for things like pavement batter, for instance, we can, in all these layers actually, we can tell it to create subgrade strings for us. So normally it's just the last one you're interested in. So I've turned on the subgrade strings for particular layers to suit the edge treatments or outside this bottom subgrade tin here. So obviously the model that they get placed on is under the reference style. So it's under the model called sub pavement and so forth. So that will be the model that gets created if you've got that layer turned on. So if I go down to here, I've got a whole lot of these ones here, and I can add those sub layers on, and I've got strings in here. So again, you can add on all those sub layers and so forth. So you're getting sub strings created to do with whatever layer you've turned on. So obviously there's a bit of work in regards to how to create that surface from there. So there is an option under here called subgrade create tins. If I go and grab one for that side, it allows you to pick a reference alignment and the model that these belong to. So there's a model for this one, there's a model for the little bit of Pavement Only, and a bit of the Verge one under here. So there's I've turned it on for all those three profiles, and it's created these strings for me. So rather than create an individual tin, so it will create one for this part of the road, one for that small bit there, and one for this bit, you can create one tin from all the tins above. In that case, the individual ones won't get created. You'll end up with a tin called sub pavement RS10 subgrade. So I process that, and then so again, wait till it says finish. It goes through a few options, and if I add in the model now, I want subgrade RS10, it creates that tin surface for me. So if I go F2, you'll see that the surface is all one tin, and there's a gap in the middle, and then that is filled by the subgrade underneath the coloured tin pavement. So again, on this side of the road, we have the RS20, similar situation. We're going to take those strings, and it will create a tin surface for me. So I want that one subgrade surface. So the idea is that the tins created, there's one here, 2, 3 and 4. If you then want to create a super tin of those surfaces, you then are able to do your normal subgrade volumes. Again, under the design volumes, there's an option here to do tri-mesh. You can do just a complete volume report on any one that you want, name and so forth, or you can do tri-mesh volumes along a string. So in that case here, if I brought this up and it had a model in here, so we said it gives us all to do with design mesh 20, and I go report. So again, you've got all the different mesh types You can collate by model, by name, and so forth. And it has a option down the bottom here, how many AC14s and so forth that you had. So it does give you the option to be able to create these surfaces either from your construction or even your post design. You can treat this as a design surface and run your pavements via a coloured tin and do edge treatments. So you have the choice to do either or. Hopefully they give you an idea of again, refer to previous videos on setting up the Snippet Attributes and a bit more information on the Design MTF. If you want to write and read the Pavement Attributes, there's a read write here, and that will then create and write out a file with the extension 12D PM for pavement management, and you can place those in user libraries and read those in at any time you want. Again, if we have a look at finally at the road we looked at in the first place, this is a combination road. So again, obviously it has gone through the same process. We have our main road running through, which we've defined our MTF from, created our polygons, and coloured pavements associated with those polygons. The polygons on the side roads are simply just created as well, so you have skills in being able to join those polygons together. All I suggest is that when the strings go to a point, come back a few millimeters so you get a bit of a square edge on the tin to make it a little bit easier to create the surface. Again, that's what we're looking at. So we end up with a pavement, design mesh pavement for the side road. Okay, is separate, and then we've got the ones for the road itself. In this case here, we've coloured the tin surface, and we've also then created a triangulation for just the top of the islands, and then we've also then applied the pavement for that as well. So again, we just picked up the colour for the islands and either use the actual colour, or we've got no colour for the strings themselves. So we're able to create all those strings and produce all the profiles for the curb and so forth as well. So thank you very much. I hope you'll be able to do some good construction work in pavements.